Hello, everyone. I hope that you can hear me. I'm really happy to have you there for our fifth session of the series DSO Innovation Briefing. Let me just load up the slide, and we will start the presentation in 1 or 2 minutes. For the people also to join the call, I hope you are all doing very well, and thank you so much for joining us for this presentation. Yeah, we'll start in 1 minute, let's say.
Paul, we already see the high-level summary slide. So maybe you can go to the first slide and lock the switching for the audience.
It's still loading to me. It's still loading to me, so I'll go to the yeah, once I can, I'll go to the beginning of the presentation. I think my connection from my computer is unfortunately very weak. So yeah. Is hello, are you able to see the presentation from the beginning?
Yes.
Okay, perfect. So I think then we can start, and people will join during the call. So hello, everyone. For those who for those who don't know me, I'm Paul Houillet, policy officer at Current. And for those who are familiar with the series, it's a fifth episode of the series on the DSO innovation briefing. So to briefly introduce Current Europe is the voice of innovative green technologies, and our members are manufacturers of technologies that help to optimize our existing network, but also help to build the network of the future. And we are launching this series with a clear mission to bridge the gap between high-level innovation and the practical wide-scale deployment that we urgently need into Europe's grid. As you all know, the energy transition is moving at a pace that is far outstripping our physical infrastructure. And to meet this challenge, the idea was to look beyond traditional reinforcement and start optimizing our existing network with market-ready, fast technologies. And today we are diving into a very market-ready technology that is digital twins. And we are thrilled to welcome Niels Weber as our speaker today. But before I hand it over to you, Niels, there are 2 quick notes. This session is being recorded. This is to ensure that we're building a library for your colleague that couldn't join today. And second point, we will have a Q&A at the end for 30 minutes. So if you have any question, you can ask them in the chat, and I will either ask them at the end or during the presentation if it's relevant. And of course, I will allow you to ask question directly to unmute you and ask a question either in the chat or with your own microphone. But yeah, that's it for the introduction. But maybe let me introduce you to today's speaker, Niels Weber. Niels, you're working since 10 years with Integra. Integra is the software and service company that is developing private tech solution. So you're responsible for the global business development. You're actively working in several working groups. You're the co-author of several technical papers. I think we're going to discuss that a little bit about digital twin in power system. And you're also the co-founder of Prime Tech North America and a member of the management board. So that's a very, very impressive CV. So for the agenda today, as you can see, the presentation is split into parts. The first one being the high-level introduction of what is the digital twin, why we need digital twin, and all the regulatory and legal aspects of it. And the second part is more the technical deeper dive, the difference between Scan-to-BIM and Scan-to-Twin, and of course, use cases and recommendation for DSOs, and then at the end we're gonna have Q&A. So maybe to start, I'm gonna ask you a question. I don't know if I can use. Oh, the Slido seems that not working with the PowerPoint live. So I will have to move to the presentation. So sorry for the delay. I'll just let me give you one or 2 minutes to stop sharing and start sharing my window so that we can all answer questions in the audience.
Otherwise, everybody needs to turn on the video and raise the hand manually. That's the alternative solution.
Maybe we can. That sounds like a good idea. But let me present it that way, because then we can really see the results directly from the other.
So raising the hand should work here in Teams as well.
Stop. Well, sorry. This is not working super well, but in the meantime, you can think about all the questions that you have for digital twin, and to ask them at the end. Okay, this is still loading. Apologies for the convenience. Well, it doesn't seem to work on my side, so maybe Niels, you can.
Yeah, I can gladly take it then from here. So let's try it a little interactive. It's spontaneous, yes. But I think you're all highly motivated to participate in a poll. So the basic question that I have in regularly these sessions is, what is your experience level with digital twins, right? Is it something that you're new to? Is it something that your colleagues are working on? Is that something you have already some pilots with? Is it that you're working with digital twins every day? Or you don't believe in digital twins at all because this is just some marketing and some people try to sell you something? So I would pick two of these questions, the most polarizing ones. So whoever thinks that digital twin is only marketing should please raise the hand. No worries, we will not contact you later and blame you for anything. If there's anybody believing that digital twins is marketing only. Good, doesn't seem to be the case. Who is new to digital twins? Who is not yet experienced with any digital twin technology, but eager to learn here in the presentation should quickly raise the hand if that works. Okay, a couple.
Okay,
but then I need to ask who has already done a pilot with digital twins in their professional life or maybe in private life. I'm curious, is there anybody who has already first-hand experience working with digital twins? Okay, then it's my job to convince you today that it's a really good idea to start working with digital twins. And let's actually then jump in the presentation. I will then share my screen here. I will optimize it for videos because we will have quite a few presentations or quite a few parts today that are shown as videos, and I think they're really impressive understanding what digital twin technology actually is. But first of all, thank you, Paul, for organizing that. Thank you all for joining. It's one of my most favorite topics to talk about, this digital twin topic, because there is a lot out there, but not a lot which is really structured in terms of what it is, what value it should create, and so on. So I want to start with this slide here that explains the starting of this digital twin concept. There was a working group within the VDE, a German organization, that looked specifically for what is a digital twin in the network and electricity industry. And it was a working group where I was also part of, and it was, I think, 1.5 years long lasting. And it was quite an intense discussion what it actually is, what a digital twin is, what value should it provide, and so on. And you can see all the organizations and companies and universities and utilities discussing this in the workshops and in the paper eventually. And you can see many different perspectives. So from scientific to utilities, from contractors, software suppliers, and so on and so on. And I really think that this is one of the best working groups I ever participated, because first of all, it's still ongoing. After the publication of this study, there is now a second stage of this working group, which divided into subgroups where they're still progressing. One subgroup is, for example, about data quality. The other subgroup is about applications of use cases and so on. And if some of you are joining the CIGRE conference in Paris, let us know. There will be 2 workshops on the recent results of this continuation of the working group. And why this working group was so effective and so good is actually demonstrated by ENTSO-E picking up on this topic together with some European utilities and bringing this to another step to a European level, really trying to understand that there's some education needed, and they brought this on a paper. Paul will paste in the chat the links of these 2 papers so you can check them out later. But I try to summarize it for you today already, that you get the most important information out of that. So let us start with what these digital twins are actually supposed to be. And I don't want to go into description of long texts and reading that. In my opinion, it is 3 main aspects. The first aspect is that when we talk about digital twins, that they always integrate a functional description, a functional simulation aspect of the assets. So if I'm talking about the electricity grid, I do want to have the functional of electricity. I do want to have the capabilities of switching on and offline, for example. So it goes beyond a 3D model with attributes. That's the core aspect of this point here. The second one is that a digital twin is a combination of multiple data silos. So in case you were thinking digital twin is marketing, you might be right, because a lot of people are using it for marketing terms. But digital twin is something that combines several data silos, and by the combination and by the integration of data silos, you actually create value by cleaner, more valid data, and you can actually reduce the data chaos. So combining 2 domains or 2 silos or 2 softwares, this is where digital twin actually starts. And the last 2 items are similar, where it's they're communicating over the asset lifecycle. So a digital twin goes through the complete asset lifecycle of the actual asset. How this can look in a more graphical way, don't be afraid of this little overwhelming slide. I will guide you through step by step, starting here in the beginning, where you see on the top the life cycle of a typical asset. So going from planning and design, construction, operation, and eventually disposal. We do have the real object. We do have the real object connected through interfaces with a digital twin. And the interesting aspect is here that the digital twin can create a snapshot twin. So let's say you want to simulate how the grid behaves if you change something in the grid. So you can load these snapshots into a simulation, try some scenarios, maybe overloading the grid, maybe trying dynamic line ratings and so on. And when you're happy with the result, you can float that back to the digital twin that is eventually managing the real object. So that's the overall idea. You can see here on the left side that this is a kind of circular circular environment where the data models, they create data analytics, insights, and this information is then used for steering the actual asset. And when the asset is operating, it collects additional data, and the digital twin can use this data again for optimizing the technology, right? So that's more or less the understanding of this digital twin in a life cycle perspective. But the question that quickly comes is, what value should it actually provide? So why do I need digital twins? And I highly suggest reading the paper from ENTSO-E and VDE just in terms of what it actually brings. But I try to find out the most critical items. And in my opinion, it all starts with a skilled labor shortage that we're all facing globally, actually. So we have less and less people in the industry. We have less and less people coming new to the job market, and more people are retiring. So we have a weird situation where experts with 30, 40 years of experience go to retirement. With their retirement goes a lot of knowledge. So less experienced people will have to deal with the grid. So the idea of a digital twin is to embed the knowledge that is out there into systems, into IT, so that the workforce that we have, and which is also savvy for IT solutions, can work more efficiently and has this digitalized knowledge. The other thing which is dominant all over the world is the change of the energy system. We have so many new electricity producers, wind, solar, and so on. We have electric cars, we have electric heat pumps, we have data centers coming up with a huge consumption. So there's a lot to rebuild in the energy grid in order to be, at some point of time, CO2 neutral in the overall European industries. So there's a lot happening, meaning that less people have to do more, right? That's complicated. Lastly, we see the prices exploding. If you look at cost of transformer, if you look at the cost of design and engineering tasks, they're all exploding because the demand is so high. So cost efficiency is something where digital twins are supposed to help. We do have a very unfortunate situation today. We call it a digital paradox that should actually describe the situation that over the last 2-3 decades, there was a huge investment into digital solutions. But unfortunately, there was not huge outcome of this investments, right? And the reason for that is that digitalization was always done as siloed projects. They were not really integrating into each other, creating data chaos. So the digitalization efforts so far didn't pay off. And digital twins should solve that by the structured approach, organizing industries and grid operators, but also their contractors. Lastly, also, I think why many of you might join here, we have the EU grid package. So there are recommendations coming that clearly point out the possibilities of digitalization and digital twins because the EU, and I think it's currently within the EU Commission, are seeing the big potentials of using new technology in our industry. So another complex looking slide, but also here, let me guide you through step by step. It explains really well the concept of how a digital twin becomes a federated digital twin. So on the left side here, you see a subsystem of a digital twin. In this case, a transformer, and a transformer itself can have a digital twin, right? It has reporting, analytics, predictions, and all of these digital twin capabilities can live within a transformer. This transformer is here in an example in a Vault City substation. This will, in the Vault City, this is part of the digital twin substation of the Vault City, which is then above on the TSO level is a digital twin, and above would be something like the European grid. So the idea is that you think that from the bottom upwards, that individual devices such as a transformer or manufacturer digital twins deliver into the component, deliver into the DSO grid, deliver into the TSO grid, deliver into a European level. So that's the understanding of how this all should integrate into each other. And of course, it also integrates horizontally, as we do have sectors such as EV charging, heating at home, and renewables that are also subsystems that could be connected to this digital twin. Now, might sound complicated, but I will surely show you a few use cases that explain this. That's not as complicated as this graphic might look in the first place. We do have to look at legal and regulatory aspects. We all know that we are working in a highly regulated industry. We are working with critical infrastructure, so it's not only a green field where we're operating and can do whatever we want. There are a lot of regulations, and there are European regulations. There are, again, nationalized European rules. There are individual national rules. There are security standard frameworks such as ISO 20007, and there are, of course, a lot of national and also sector-specific regulation. Not talking about all the IEEE, IEC standards that are on a technical side. This is more the legal and regulatory aspects that are all influencing this digital twin and data hosting and processing generally. And at the end of the presentation, we will look at this one here again and see how digital twins pay into these several legal and regulatory aspects. So, unfortunately, the next slide is something we cannot process again, but the question that I have to you basically is to think about how good is the data that you have today using digital twin technology or automizing processes, right? We coming from a background of substation design and engineering software, we talk about a lot with users who work daily with existing grid infrastructure, who work with legacy documentation, sometimes PDFs, sometimes even hand drawings that are 30, 40, even 50 years old. So we do have an existing grid, and the documentation of the existing grid is rather poor. And this is a study that we also did at a secret conference, and over 70% of the people said that our data in terms of, in this case, substation design and substation asset data is poor or very poor. So that means eventually that if your data is poor, how can you integrate digital twin technology? And this is quite a big challenge. It's also one of the recommendations from the VDE study, where it says that implementing digital twin technology means that you need to integrate it for all of your assets, right? Even though we're building a lot of new infrastructure, we build a lot of new transmission lines, we build a lot of new substations, nevertheless, it's just a small percentage of the grid that we already have. So in order to leverage digital twin technology, you do want to have a digital twin for all of your assets and not only 10, 20, or 30% of your assets. Otherwise, you would not really change an organization if this is just a use case that applies in 20% of the time. So that's a little bit background, right? We see a lot of challenges with the legacy documentation, and the legacy documentation, we call it in Germany, is the sand in the gears, right? So the gears are trying to operate, but there's a little sand in there, and it's really not as smooth as it's supposed to be because you're all the time busy with validating your data, with checking what you actually have. And we discovered this problem already many years ago, and we thought, how can we actually solve this, right? How can we bring the existing grid assets into a digital twin ready environment? And I want to show you here a small video that explains our digital twin factory. The idea of the digital twin factory is to digitalize existing substation infrastructure in a highly standardized process, really efficiently. Hundreds of substations per year can be digitalized so that you get from unreliable data to really trusted data environment. And I let the video speak for itself, and I'm really curious if there are some questions later to discuss on that. But first, let me ensure that I'm also sharing the sound here. If Paul, you could give me a thumbs up if the sound works, that would be great.
The energy transition transforms power grids across the globe. Existing substations need to be rebuilt and expanded, but many utilities face the same obstacles: outdated documentation and unreliable asset data. This slows projects down and complicates daily operations that rely on the knowledge of a few individuals. Primtech's digitalization service OSR Plus Pro solves this by creating an accurate digital inventory of the real substation, a data-driven foundation for design, engineering, and operation. The process starts on site. After georeferencing the location, a scanning team prepares the survey works. A terrestrial laser scanner captures the substation step by step, producing a detailed 3D point cloud. To avoid shadowing, the surveyor moves in closed loops. With an area of around 100 square meters covered per scan, the entire substation can be scanned in less than a day. At the same time, the nameplates of all high-voltage equipment are photographed. This information is essential for modeling the electrical behavior of the station and helps clean up legacy data to update the asset information model. Along with the point cloud and the nameplates captured on site, the utility provides existing asset data and the single-line diagram. These 4 data sources form the foundation of the digitalization process and are initially reviewed by a substation expert. A specialized AI tool is used to compare legacy asset data with on-site information, linking each piece of equipment to the corresponding asset database entity. This essential step ensures all asset information is available and correct. All inputs are the source materials in a digital manufacturing process, which is based on the philosophy of a traditional production line with clearly defined tasks and quality gates. In this digital twin factory, multiple designers work simultaneously on the same substation. Everything inside the station fence is processed. In addition to the terrain, the operations building and all other infrastructure elements are modeled. However, the core of the substation are the electrical assemblies. The OSR Plus Pro service leverages years of AI model teaching based on a large equipment library. This technology is unique and a key reason why the digital twin factory is so efficient. During the modeling, AI detects conductors within the point cloud and automatically models them to connect the devices. The high degree of standardization, automation, and scalability enables the Primtech team to produce hundreds of intelligent substation models in a very short time at consistent quality. Despite this high level of automation, a human expert always stays in the loop, validating and refining the automated process. In the end, a substation engineer performs a final quality check, making sure that the model's electrical functions are correct. A compliance report outlines clearance violations and assesses lightning protection. In the final stage of this check, standardized drawings are approved and a report is created, highlighting issues in the legacy asset documentation. Only after this final validation is the digital twin ready for delivery to the client. For grid operators, the digital twin is an invaluable asset. The intelligent BIM model delivers a precise engineering view of the substation to accelerate brownfield projects, but its value goes far beyond design and construction. With one click, the BIM model is transformed into an always up-to-date virtual reality model. Providing a comprehensive interface with file sizes of only a few megabytes, the model is easily accessible to all stakeholders, including asset and operations teams. By connecting asset management and ERP systems according to the single source of truth principle, the VR model turns into a true digital twin of the substation. Use cases across the organization are enormous when model and reality start to overlap. With Primtech's digital twins, operators establish a valid data foundation for any technological advancement, such as IoT condition monitoring, predictive maintenance, and AI-driven applications, ultimately preparing their grid for digital transformation. Start your digital inventory now with Primtech OSR Plus Pro and create the data transparency you need to drive the grid expansion forward.
Perfect. I think that explains really well this concept of digital twin factory with the target to provide, as I mentioned before, highly trusted data to speed up processes and to automate processes at the end of the day in a digital environment. With this, actually, we try to solve one more problem that is currently discussed in the VDE organization as well. And I, again, gladly invite you to the SEGRO conference in Paris to join this discussion because one of the major topics is what is data quality, right? Everybody talks about we need good data, we need quality data, but nobody has criteria on what good data is and what bad data is. And with this digital twin factory, it's one example where we define quality gates, right? And then it says clearly what needs to be accurate, what is the tolerances, and all this. It's not existing in the digital environment. We have this in manufacturing processes. When you create, I don't know, here a pen, when it's 1 millimeter too long, it's not good. When it's a millimeter too short, it's not good. Everything in between is fine. And this is just missing currently in the digital world. And in the VDE, we try to solve this really complicated topic, but with great progress. So again, visit us in Paris and let's have a coffee, tea, beer, or whatever you prefer. Okay, how to summarize that? A few topics that are, in my opinion, important from these two studies is The first one, this is a journey for us as an industry, right? It's technological disruptions, it's organizational changes. We have existing workforce. We need to be upskilled in some sense. Everything becomes more IT heavy, and we need to be to get this knowledge to be able to transform organizations to this journey, which is an exciting one, but it is something that can also scare people at some point of time. But it becomes really clear that the potential of digital twins is essential, and it is a kind of integration layer that you need to manage in an organization, implement that between departments, silos, softwares, and so on and so on. Eventually, everybody is today talking about AI technology and the beautiful things it can do, but everybody who has tried AI technology also sees the limitation of that really, really quickly. And imagine now that you feed AI applications with unreliable data, and you feed AI system with unstructured data from a few substations. So this will be rather complicated for the AI to make predictions that are correct. But to be honest, in a grid environment, we cannot rely on unreliable AI predictions. So we do need this validation of the data in order to leverage the technology that AI can bring in our day-to-day operation. One message will become really clear once you look into this digital twin thinking is it's not something that you can just buy, right? Utilities have sometimes big pockets and huge budgets spending for the grid infrastructure, but unfortunately, digital twin is nothing where you can just write a check and get it. This is something that you need to integrate. I call it like an orchestra of solution. You have different disciplines, different providers, different tools that need to be integrated. So it's nothing out of the box. This is a journey that we all together in utility and all of their suppliers at the end of the day. And the conclusion of this ENTSO-E report is that grid operators become somehow system operators. They need to integrate these systems for digital twins. Yeah, so far about the high-level summary. Now comes the exciting part with the technical deep dive. Really looking forward for this aspect. And I think we are good in time, so we can really go through all the use cases that I have planned for you today. So we mentioned that digital twin is a journey, right? You need to get to this point where the world is beautiful, everything is talking to each other, everything is automated at some point of time. It's a vision, right? But it's a journey. And how this journey could, for example, look like for digitalization of substation, we have here a kind of like milestones to be achieved. And we've seen several journeys from several utilities that stop at some point of time, unfortunately. Of course, every utility is having assets, real substations, right? And there are a lot of programs currently in place where LiDAR and point cloud scanning technology is used for capturing the sites. The reason for this is obviously the data that they have is just not valid, and that's why laser scanning is a great technology for capturing what is on site and bring that to back to the organization. The limitations of the LiDAR scan is, of course, it's just 3D measurements, right? There is no simulation capabilities. There is really heavy file sizes. It's nothing that you can easily use on a day-to-day basis apart from measuring. And unfortunately, laser scan gets old in the moment you leave the substation, right? So next day, device replacements happened and your LiDAR scanning technology is outdated. So the next progression of that, or the next step, would be to create 3D BIM models based on this point cloud, right? It would be a much smaller file size, much better to handle. You can use it for creating drawings. You can use that for creating bill of materials. So that would be the next step for leveraging digital data. And eventually we do have the connected digital twin that is really integrated from one system to the other and has the simulation capabilities that I mentioned. Yeah, let's quickly compare what the difference actually is between the Scan-to-BIM and Scan-to-Twin, because both, especially the Scan-to-BIM process is more and more established, but it does have some limitations. And I think this is a great slide explaining this. When you see this scan-to-twin process, it includes the validation step of not only the geometry, but also from the asset management data. You saw in the video, for example, that there were pictures taken from device nameplates, and these device nameplates can be compared to existing asset management databases, and based on this, it can be validated. So the idea is that the BIM database model is then connected with an asset database model where you validate, harmonize, and connect data, and you get a really, really high validity that is AI ready, that is really ready for automations. In comparison to that, we do have the Scan-to-BIM process, and this is only a partial validation of aspects, because the only thing that is typically validated is the geometry, right? So you have an old 2D paper which is documented, and you create a geometrically correct 3D model out of that. So that is a typical Scan-to-BIM approach, and they look at the asset management data and copy the data into the BIM model, into the BIM file. So yeah, the files does have big limitations and integrations, and just copying attributes in the asset database is unfortunately coming with huge uncertainty. According to studies also from SIGRE and VDE, only around 60–70% of the data is valid, structured, and usable for that. So that's not really what you need in terms of automating things and leveraging the digital twin technology. Yeah, that being said, maybe structuring a little the benefits that we have from Scan-to-BIM and the benefits from Scan-to-Twin processes with customers and grid operators, where we digitalize the complete grid already. They have a huge benefit in terms of the brownfield projects, right? As we all know, the market is so hot and so much demand for resources. The prices increase tremendously, and contractors can actually pick the projects they want, right? Projects that are risky, projects that are uncertain, they don't want to take when you can have an easy greenfield station or another easy project. So the idea of a Scan-to-Twin and Scan-to-BIM, in this case, a Scan-to-BIM approach, is to provide data that is trustworthy to work on. We have seen utilities that report a 30% decreased price just because the risk margin shrinks by having this validation level of the data. On the timeline, we can see that the data collection before a project starts and having the data ready in the hand the moment you need it creates a 4-week time benefit to start your projects. You can read on our website a reference story with some utilities from the E.ON group who report exactly this increase in efficiency. And it's not underestimated that this also means a lot more fun working, right? I think for changing an organization, the new technology needs to prove worthiness, and it needs to be better than the existing workflow. And everybody loves working on problems and not really working on, is PDF version 1 or PDF version 2 from 30 years the actual correct data. So I'm a big fan of having fun at work. So this is why I think it's not only time, it's also less frustration having these models available. And the moment you start having a validated model, the change orders and the complications and communications in the projects are a lot decreased, of course. In contrast to that, looking a little into one step further, which would be the benefits of a connected digital twin, where we talk about the single source of truth principle. That means that every data is only stored at one location and connected to the other databases. It's easy accessible to everybody, so we have not copies and redundancies of files flying around. We do have trusted data, we do have linked data, and you can also access information much easier than logging into asset management software, for example. You use it just once or twice a year, and then you need to find out your tables and search for your information. And I will show you a video how easily a digital twin can make data accessible. The other the other aspect worth looking is the work preparation, safety trainings, and so on, right? If you do have a clear model with logical connections and safety zones, for example, you can easily use that for training and onboard new people in the in your grid and operation and in your organization, and of course stakeholder presentations, guided tours, and all that. This is something we will explore together in the next 10 to 15 minutes. Of course, mentioning the simulation capabilities, simulating power flows, doing brownfield studies, and using VR technology. But before I come to the fun parts of use cases, some of you might have heard or read the news a couple of weeks ago in Germany, I think 20, 30 kilometers here from our office. There was, I actually call it a terror attack to our grid infrastructure. And if you follow the news more or less frequently, you will see that this is an increasing problem. There are some crazy people out there who have problems with our grid infrastructure, and we are a quite vulnerable society. We are dependent on electricity, and we have seen a couple of weeks ago somebody trying to set the substation on fire. The substation broke down with some cables, and a couple of days there was no electricity, and this is something really, really critical for a modern society as we are. And it is also, when we look at regulation and legal aspects, we do need to protect our grid infrastructure. And one thing, one aspect of protection is knowing clearly what you have, knowing clearly how the redundancies are organized in order to be fast in case something happens, or even better, use the digital data to prevent terror attacks like this by knowing the weaknesses of your assets and building a more resilient grid. So something new to the presentations that I usually do, but I think definitely worth looking into. It happens more and more frequently, and it's a big threat to our society, in my opinion. Yeah, but let's look into the more positive, a little more fun use cases, where a few of them I want to present to you today. It will go from conceptual design, building new assets, to verifying what you actually build, communication between stakeholders and between departments with BIM collaboration workflows. We'll quickly talk about VR trainings and onboardings, and two use cases that we have developed together with TransnetBW and Amprion, which is about stakeholder communication and electrical simulations for sim asset data in this case. And I gladly start here backwards. So the use case that we did together with Amprion was exactly that. We digitalized an existing substation. We connected the existing asset management system based on sim data to the BIM model that we provided. And by that, we could really leverage two systems talking to each other and getting a clear idea of how the asset looks like. There was also a paper written about it, also in VDE, so it's also really interesting to read, but unfortunately not translated to English. But in case you reach out, I can gladly provide you some insights here into this project. But let's look here at another video, how this project was conducted. And it starts here with this integration of digital twins, connecting asset data, connecting nameplate information, having here the simulation capabilities where you can switch in a substation some parts offline, and you see it's a huge station. It's a 380 kV, another 220 and 110 kV station, altogether over 50 bays. So it's one of the biggest stations we have in Europe. And the idea here is to use a filtering system to filter data from the asset management system and visualize it here in the VR digital twin environment. And you can see now here that this is visually representing a device replacement period, right? Green means it's good for the next 15 years. Yellow means it's good for the next 5 years, and red, something that you need to replace within the next, yellow 10 years and red 5 years. So the idea is here to make data easily accessible, give them context, and give them a much better representation than reading remaining life cycle time in an Excel sheet, and then you read bay number 540 in substation somewhere, right? So that's much easier data to be processed for us as humans. Yeah, the next one is in the case that we need to build new infrastructure, and just give me 1 second here. If we need to build new infrastructure, extend existing substation, for example, coming in a new wind park or a new solar power plant or something, you want to quickly make a feasibility study, you want to make some concepts if there is space around at the substation, and I want to show you in a small video how this could look like, having a digital twin in hand, so you can really quickly make decisions early in the project and make sure that this runs later throughout the processes. So how this looks like here, these are some of the features that are here in experimental state. So you can select, for example, an existing bay that you want to copy here in your station, and conceptually you can move this around in the VR environment. So there's no CAD experience required, right? And you can move this around, connect it to your bus bar and see if there's sufficient space for your extension project. For example, you could also connect into you could also copy several individual assemblies and devices, and you get here an idea of how this looks like. Why this is important? Because how this process is done today, sometimes people just look on Google Maps, print this out, and on PowerPoint you see some conceptual designs being done. And to be honest, I think it's a terrible process because people admitting that Google Maps has better data than they have in the document management system. So this is a much better way of actually really testing if there is sufficient space and sufficient, if there's a concept possible or extension possible in your substation or not. So that's one of the other examples. So building new assets, assuming now that we have built new assets, the next step is, of course, to verify if the modeling, if the construction was according to your plans, right? And whatever you plan, reality hits hard, and sometimes you need to be creative at the construction site and improvise, and then you have the issue that what you build is a little different to what you have actually planned. In a BIM environment, you can reduce that, of course, a lot, but sometimes site conditions may be complicated, so it's important to have a validation that once something is built, you can compare this with your planning state. And here, the idea is to use, again, laser scanning technology, that after an asset was constructed, you do a laser scan and make an overlay of the point cloud against your BIM model, and you can quickly see whether there are some deviations, and you need to have a discussion about that. Based on our experience, these deviations can be rather big. One of the first pilots we did, there was the gantry of the substation 2 meters placed at a different location. And if you think about having 2 meter more or less distance in a substation, can be quite critical for the operation. So you have different electromechanical forces, you have different clearances, and this can cause actual danger to the people being on site, but also, of course, for the grid operation in the future, because all your studies and results that you did beforehand are not working. So this is a great way of validating what you have built in your grid infrastructure. And we're currently working on an automated as-built verification. And this is a first preview where you can see that green means everything is within the tolerances that you assume, and once it's get red, you would see that, hey, this is maybe something I need to look at. There's some tolerances that are not matched, so maybe I should look at that more closely. So just a preview here, but interesting way of making sure automated that the substations and the assets you build are actually correct. Yeah. When we talk about breaking down silos, it's a lot about working together, right? So there are actual standards out there that can help us and support us in this. One of that is the open BIM standard BCF, BIM collaboration format, that can be used to bridge information from one software system to the other. And in this case, it is, for example, used in the design software where you do the actual editing of your BIM model. So you can see here a transformer that I maybe want to move or do something with it. And in the VR model where you can access the same information from the BIM collaboration format and use in two different systems, connect them by a communication layer with the BIM collaboration workflow. I do not have a video today here, but on our website, for example, you can see how this process really flows through the organization and helps a lot in communication here. Yeah. The other one that I wanted to mention today is the stakeholder communication. Stakeholders can be many different kinds of stakeholders. They have, in this case, this is a project from TransnetBW. This is the mayor from the substation site Wendlingen. And TransnetBW has a huge project over, I think, the next 10, 12 years with a lot of construction and build of the infrastructure. And the bigger the station, the more public complaints you might have, right? And the idea from TransnetBW was to use VR technology, to use modern technology to positively influence or just positively report about a project and try to engage with neighbors, politicians, regulators, and so on. And we did with them a kind of VR tour system. And I will show you how easily this is to be set up. But of course, as a utility, you not only have stakeholders from neighbors and politicians, sometimes stakeholders are just different departments, right? Sometimes stakeholders are new talents from universities that you want to acquire in your organization, because we're all competing about a few resources human-wise that we have, and having a modern work environment on trade shows for jobs, for example, this is a tool that can be used very efficiently. For this, I created a quick video for you, so you can also see how easy it is to create a tour for stakeholder communication in a digital twin environment.
Windows mode activated.
So what I do
Select
here
terrain.
is I have here some terrain data that is
Processing.
imported. In this case, it imports 3D topology. It imports pictures from satellites. It imports buildings, and you can now place your substation locally where it's actually supposed to be. It's just a demo, so I just place it here at a given field. I can rotate it, of course, and fit it in perfectly. Then I want to decorate my station a little. Substation is a lot about hiding the infrastructure, right? So I'm trying to plant here some nice trees, so the public will not really see my substations, for example. Let's additionally here place a rotating wind turbine. Let's maybe rotate it a little so it looks in the right direction, scale it a little. So a nice, easy way to edit here this model. You can use here some cars and bring them to the station. Also make this a little bigger, maybe rotate it in a different driving direction. Then using some pylons or let's place some colleagues here in my station. That being completed, let's go to my pylons and secure this area, for example. So it should show you how easy and how quickly you can modify a model like this. And maybe let's close it here with our boom lift. You will see at the end why this is important. So this is an item that can really be used later for simulating operation and maintenance work. So I prepared my scene,
First person mode
right?
activated.
And now I want to create some points of interest. So I want to go here to my transformer, and I want to create here a new tour. I call it here my XR demo tour.
Select audio.
I can select a welcome audio that invites you for joining the
Select image.
the demo. Then you can have your company logo. You can quickly integrate also a tour logo. So this is my welcome tour.
Select image.
Select here maybe a Primtech logo from our side, and then start creating points of interest. So my first point of interest is here, transformer. I want to inform somebody what a transformer is doing. Have a quick audio connected to this, and store this point of interest. Then I want to go over here, passing my colleague, my truck, going to my boom lift. And you see here already this red circle illustrating that you can do something with it. So let's call it my boom lift tour. Also here, select another audio, and have here an activation radius. So you can see this tour as well. And now, simulate tour.
Welcome to today's presentation of Primtech DT Tour feature.
So you can choose between guided and self-guided.
A high voltage transformer steps up voltage for efficient, long-distance power transmission with minimal energy loss, or steps down for safe distribution to industries and homes.
First person mode activated.
Now you can even hear the humming of the transformer, and you see your boom lift. The moment I go away, the transformer sound becomes lower.
Have you ever been on a boom lift? Try it. Just click on the button.
So now I have here my activated boom lift. I can click on moving up. And you can get a clear, nice idea of the surrounding, of course, and go up to your overhead lines and do a repair or a maintenance job that needs to be done here. Yeah, so that's the idea here of using this digital twin environment. You might hear the birds in the background, how they are simulating a little positive nature feeling. And I'm up now with my lift here. Yeah, and when some of our customers saw that, they were like, oh, wow, this is impressive, but I don't want to use it for stakeholder communication. I want to actually use that for training people, right? You saw in this model how you can simulate a power flow, how you could simulate phase distances or safety clearances. And that's why we are now developing a safety training and a simulator tool where you can then get on personal protective equipment, such as wearing a helmet, wearing gloves, wearing the right shoes, and then having a switching order, going from one station to the other station, going to different pieces of the substation and do something in order to complete the maintenance tasks. For example, in the end, you get a verification that you passed the test. So that's something that we are currently developing based on the great foundation technology that we have here. So now looking at all of these potential use cases in a digital twin environment, I want to structure them a little in terms of where on my asset lifecycle are they actually happening. So we have here the asset lifecycle again, design, construction, commissioning, operation, maintenance, and decommissioning at the end of the day. And we all know that our substation or grid infrastructure is built for decades. So this can be a quite long operation and maintenance phase. And we have seen the simulation asset management use cases that are actually passing across the complete asset life cycle. We have seen the conceptual design here early in the design phase where a lot of projects are currently stuck. We do have the as-built verification that you use then afterwards. You have the BIM collaboration workflows that also go across design, operation, and maintenance tasks, stakeholder communication, of course, and training here again in the operation and maintenance aspect. Yeah. So you can see for every lifecycle phase, there is something for digital twins to gain from. And if we now look in concluding this presentation and also coming soon to the question and answer part, I want to look with you again to the legal and regulatory aspects that we looked in the beginning, right? And we have all these norms and regulations that we need to comply with, and we need to comply with them also on a digital level, right? So data protection, standardization of workflows, grid resilience, resilience infrastructure. And our technology here, especially with the single source of truth principle, so we have consistent data across the life cycle linked from one system to the other. We can evaluate physical security that you saw in the crisis management phase. You can quickly use models and digital twins to come to a state where the grid is operational again. For audit and documentations. This is, of course, really helpful that your documentation and records are 100% correct, and yeah, using documentation across the life cycle. We mentioned that already. So if you think, okay, nice, sounds good, but where to start? So much to do, so many projects to do, and I don't have time for any of that. There are some clear recommendations how to start the action, right? And one of the first clear recommendations is don't implement silo systems, right? Don't implement new files and file formats that are siloed. Try to break down these silos. Try to implement database technology that can communicate with each other easily and really make sure that data remains consistent over the asset life cycle by using single source of truth principle. But at the end of the day, you will have to go through a digital data inventory, right? In order to change organizations, you need to tackle the problem of your legacy data. Otherwise, digital twins will start as a nice pilot and will exactly remain a nice pilot and not go to really changing the organizations as we need them to change. The other clear advice is don't develop digital twin based on the technological possibilities, right? It's really not a technological feature game. Digital twins should help you in your day-to-day operations, in your day-to-day tasks. So the clear recommendation, develop use cases, prioritize them, and define a migration path, where to start, what problem to solve, and get to a digital infrastructure that is talking to each other. Yeah, this is definitely crucial. So we have seen a lot of digital twin initiatives, and they're just about what is possible, but not really solving the problem of the people in the day-to-day operation. And that's the last point. If we implement digital technology, we need to think about the people using it, right? And if you just say this is our new tool and they're laggy or buggy or not working or complicated, you will not really change the organization. So whatever we implement, it should be use case driven, provide quick value as an individual measurement, and it should, of course, make fun, right? I hope you could see today in these VR environments, for example, in the digital twin environment, this is fun to work with, right? And if I look at younger generations today, they do like working with new technology, and it's in my opinion, a must-have for organizations to provide attractive jobs. And digital twin technology is surely one aspect of being an attractive employer in the competing environment. So that being said, I think we are perfectly in time. I thank you so much, everybody, for listening to this webcast today, and I would be more than happy to have some questions answered or maybe discuss a few aspects. And I think, Paul, you will be moderating this. So thank you so much again for organizing this.
Yeah, you're welcome. So thank you so much for the presentation. It was very interesting. For the audience, I enable your microphone and your camera, so you can ask a question if you want, and of course you can also ask them in the chat if you think it's necessary. But maybe to start with the question on my side, you mentioned that you are very clear that digital twin are integration layers, they are orchestral solution. So I wanted to know how you combine digital twin with other innovative solutions, in other innovative grid technologies, especially the one that we already discussed during the last briefings.
Yeah, I mean, eventually, as I mentioned, it's a kind of an integration challenge that you need to solve, and you need to build up IT competence for this, having the people on board. But the overall idea, and I think it's a great concept, the overall idea of digital twin technology allows the utility to work with the Champions League in every aspect, right? There are a lot of theories or pilots where one software should solve everything, but then you have 50% good software here, 80% good software here, 80% good software here. The idea of integrating and orchestrating digital twin technology allows the end user to work with the best-in-class tools, but integration is something they need to deliver. And for the integration, of course, database technology is fundamental, right? Databases can easily link to each other and leverage leverage each other's knowledge. And there are actually even standards for that. Becomes really technical, but if you're interested into this, there is an industry 4.0 standardization. Just forgot the name about it, but in the manufacturing industry, for example, digital twins, automated production lines is already happening today. And they're all based on these integration layers that use asset administration shells, for example. And now I just remember the word, it's RAMI 4.0, RAMI 4.0. So that's a complete architecture of how this integration works over the asset lifecycle and in between systems. Yeah. So I hope that gives you an answer to that question, but integration is crucial for sure.
Yeah, no, that's very interesting. Maybe I can ask the audience if the audience has prepared any question in the meantime, or if you need any clarification on what was presented before. Don't hesitate to raise your hand or directly take the floor. So if it's not the case, maybe I have one last question concerning access to data. You already addressed it a little bit during the presentation, but yeah, data accessibility and that data exchange, if it's easy to integrate with available data from system operators, and how to manage that the best way possible.
I'm not sure if I 100% understood the question, how to integrate the best way or how to do this thinking.
Yeah.
In my opinion, the first thing is you need to get integratable data, right? If I have here a piece of paper, it's really hard to integrate this into a digital system, right? So the first challenge is how do we get data that can be integrated? And this is why this digital data inventory that is suggested by the VDE is a must-have. So you don't have a scanned PDF from 30 years ago. The idea is to have a database that hosts the information that you actually need. And by bringing legacy data into machine-readable formats, into databases, mapping between one database and the other database is rather easy if you follow standards. Luckily, there are a lot of standards, IEC structuring of substations and grid topology, SIMS data, common information model is a great structuring approach of doing that. So there are standards available that already help us with this. And if we comply with these standards, it's rather easy because the topology of the systems based on the standards is the same. So for example, if us integrated our database into a SAP or Maximo interface, right, it's just one day of configuration where you just need to let the systems talk to each other. So it's not a IT project that goes over a month and costs thousands of dollars at the end of the day.
You know, very interesting. So I want to thank you so much for the presentation, and for the audience, you can reach out to us if you have questions after the presentation or comments on the series. We would really welcome any comments on this series, and especially on this episode. We designed it to be a beneficial tool for DSO, and I think Niels presented in a way that was very understandable for system operators on how to integrate such a technological solution. And we really want to have your feedback. So please contact us. Of course, we will keep you updated on the way forward for this series. There is one presentation left in September on superconductors, but of course there will be a follow-up email with the presentation and the slides, so you can share it among your colleagues or your network. So please feel free to do so. I really thank you, all of you, to have stayed until the end, and I wish you a very pleasant week ahead.
Yep, thank you so much again for hosting it. I hope, Mark Norton, you said in the beginning, go Niels, convince us. I hope I did. Wish you all a great day. Really appreciate it. Enjoy the rest of the day. Thank you so much, everybody.
Goodbye.
Bye.
Thank you very much. Good day.
Thank you very much.
Thank you. Bye-bye.